Hi everyone, my name is Artur Chmaro and I'm DevRel engineer in vlayer. In this presentation, I would like to focus on web proofs, also known as a zkTLS, and how you can use them in your Solidity smart contracts. I don't have much time, so let's jump straight to the agenda. It's quite simple. I will start with outlining what vlayer offers to Solidity developers, what you can do with it. Then I will briefly mention on the very high level how this works, what components are needed. Then we will go through the bounties that are available for this ETHGlobal and what you can win from vlayer with your cool project. And then I will briefly mention how to start with vlayer 2.0. So actually, why do you need web proofs as a Solidity developer? As you probably know, smart contracts are running on very isolated environments. It's rather impossible to access external data. Of course, it's fine for many existing on-chain solutions, but what if you needed to bound your Solidity smart contract to real-world assets? Oracles can't help with that most of the time because they're a really good tool, but they work well with the public data. But it's way more complicated to actually access some private balances or some identity attributes in the privacy preserving way. So for example, if you would like to access your Reddit data, your fintech application data, your banking app information about your balance, about your recent history, what you did, and so on, it's of course impossible to do with the oracles. However, thanks to zero-knowledge proofs and state-of-art cryptography, now it's possible. vlayer web proofs allow you to notarize any web-to-data call. So you can make a call to GitHub API or even some website with HTML, selectively extract piece of data, verify it, and then turn it into zero-knowledge proof that can be verified on-chain. If this sounds interesting to you, I will show you the demo, how this works. And by the way, if you would like to try this project yourself, just check the description to this video, and there you should find a link to the documentation and link to our GitHub open repository. Feel free to experiment with it on your own or even use it as a template, boilerplate for upcoming ETHGlobal. So let's see the example of the proof of contributions. So I will go to this regular Next.js application, and here we can specify the GitHub repository, so owner and repo. If it's a private repo, you need to provide us with the read access key. And then we can just provide here the handle. This repo is public, so I don't have to give any extra authentication. And now behind the scenes, we are sending a payload of what call we want to do to our web prover. And this web prover is initializing connection with the notary that is looking on the every chunk of this call between our web prover server and GitHub servers. And notary in that configuration is needed in order to actually be sure that the communication between my server and GitHub actually happened and the certificates were okay and this communication was not tampered. Because of course, if we would do some malicious action, there's a huge risk of generating the proof that is proving something that didn't happen in reality. But here, if we have a trusted notary, which is an extra party, then the notary is basically signing that this particular request happened and it was correct. And now we have a web proof. And web proof is something that we can just take to some centralized server and just verify that the signatures are matching with the notary signatures and that actually this attestation came from the certain notary. However, what if we want to bring this data on-chain? Well, it's very simple. All we have to do now is to generate a zero-knowledge proof. So if I click here, of course, it works in the mocked version of our zk prover, so it was fast. Normally, it takes a bit longer. But here now, we have public outputs out of this web proof. So we have certain data that we can insert into smart contract, Here we have the repo name, my handle from my GitHub, and the amount of pull requests that got merged into this repository. We have also a queries hash because we are taking these 3 items here using James path from the JSON that was returned from the GitHub API. The queries hash is basically calculated out of these queries that we are doing. And here we have a notary fingerprint that must be something hard-coded in our smart contract, that we are accepting attestations coming from the certain notary. And now, once we have this ZK proof here, and also this data, now it's time to actually do the on-chain verification. So now I will click on the verify on-chain. Here I have to sign the transaction with my wallet. And now you can see the success. So actually this means that the public inputs that I've sent into the smart contracts, queries hash, notary fingerprint, and the zero knowledge proofs are correct, and the data is verified. And of course, here in the smart contract, I can have a bit more logic what actually happens when the proof is verified. So in the nutshell, to build a proof of contributions, we would need 3 components. So first of all, we need a server-side web prover, which notarizes HTTP call, in that example, call to the API github.com. And here also this call is notarized by the notary that is signing the attestation. And then once we have the attestation sent back to the client, then client again can send this attestation to ZK Prover. And then this attestation goes to the ZK Prover. ZK Prover is extracting public inputs to our smart contract and creates a Growth 16 format proof that can be sent to our Solidity smart contract. And the last component is, of course, a Solidity verifier contract that can be deployed on any EVM compatible blockchain. And as long as the public inputs and the proof are correct, then the logic would be executed inside our smart contract. That's it in terms of how our web proofs are working. But now I think you are really interested what you can win from vlayer during the hackathon. So we prepared for you 4 bounties. The first one is the best ZK proving application. So if you would like to build an application that is relying on the private information, on the private data from your browser, then I think the first prize is the best one. The second one is kind of the same, but here you can use our server-side proving that I just show you. So you don't need basically any browser plugin or mobile verifier application. You can just send a request to the server, which by the way can be hosted by you, or you can use a pre-deployed infrastructure by vlayer, and then generate and verify proof on-chain. Then we have best vouch integration. Vouch is our application that simplifies accessing certain data sources from your browser or mobile verifier. So we have pre-populated catalog of data sources like proving your data from Revolut, Monzo, Wise, Instagram, Twitter, and so on. And you can just use this data inside your smart contract. The bonus bounty is the one about creating own vouch data source. So we have tools for creating a new data source inside the vouch, and then you can create a new workflow for the browser extension to just verify some data on completely new data source. And we would like to reward the best ideas for the best data sources that are missing in our catalog. And in terms of installation, I think it's quite easy. We did big progress since the last ETHGlobals, where everything wasn't so easy to control. Now we have new docs. You can head over to docs vlayer XYZ, and there you can learn how to use our web prover, ZK prover, and vouch, how to combine this into your application, how to use existing data sources, how to create the new ones. Everything is in our new docs, so I highly recommend you to check them out. Thanks for watching. I wish you all the best at the ETHGlobal. Happy coding, happy hacking, and see you there.